Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos.
Chapter 4. Metals and Non-Metals. The world around us is filled with different kinds of materials such as wood, steel, iron, wax, stone, rubber, etc. All these materials are used to make different objects. Based on their physical and chemical properties, materials may be classified as metals or non-metals. Materials which are hard and shiny in appearance are called metals, while the materials which are dull and not so hard are called non-metals. Physical properties of metals and non-metals. One can easily identify metals and non-metals on the basis of their physical properties. Some such properties are hardness, physical state, luster, malleability, ductility, sonority, etc. These properties are hardness. Metals are hard and strong, such as iron and aluminium. The exceptions are sodium, potassium and magnesium, which are soft and can be easily cut by a knife. Non-metals are generally soft and not so hard and strong, but diamond is an exception, as it is the hardest substance found in nature, though it is a non-metal, that is, a form of carbon. Physical state. Metals are solid at room temperature, with the exception of mercury and gallium, which are liquid at room temperature. Non-metals may be solids, liquids or gases. For example, phosphorus, carbon and sulfur are solid at room temperature. Oxygen, hydrogen and nitrogen are gases at room temperature, while bromine is the only non-metal which is liquid at room temperature. Shine or luster. All the metals have a metallic luster, that is, they have a shiny appearance. Some metals like gold and silver are very lustrous, that they are used to make jewelry. Non-metals are dull and do not possess any luster, with graphite being an exception. However, diamond is highly lustrous. Malleability. The property of a material to be beaten into sheets is known as malleability. Ductility. The property of a material by which it can be drawn into thin wires is known as ductility. You have seen electrical wires are thin strands of copper and aluminium, which are metals. These thin strands can be turned and twisted easily without breaking. Coal and graphite cannot be drawn into wires. This shows that non-metals are not ductile. Heat conduction. Metals are good conductors of heat. Non-metals are bad conductors of heat. But graphite, a non-metal, is an exception as it is a good conductor of heat. Sonority. The substances which produce a ringing sound when struck with a hard material is called sonorous. For example, when the bells in the school, temples or church are struck with a wooden mallet or some hard material, they produce a ringing sound, whereas non-metals do not produce any ringing sound and hence are non-sonorous. Electrical conduction. Metals are good conductors of electricity, while non-metals are bad conductors of electricity. But graphite is an exception as it is a good conductor of electricity. Silver and copper are best conductors of electricity, followed by gold and aluminium. Melting and boiling points. Metals generally have higher melting and boiling points as compared to non-metals. The exceptions are sodium and potassium, which have low melting and boiling points. This property of metals allows them to be molded into different shapes by heating or cooling. Non-metals have low melting and boiling points except graphite, which has very high melting and boiling points. Chemical properties of metals and non-metals. The characteristic demonstrated by a material during a chemical reaction is called its chemical property. Just as with physical properties, metals and non-metals differ in their ability to chemically combine with other elements and compounds. Some such chemical properties of metals and non-metals are reactions with oxygen. Metals are very reactive. They very easily react with other elements to form different compounds. Some metals, such as sodium and potassium, react with oxygen, even at room temperature. Corrosion. When certain metals are exposed to air and water for a period of time, the metal surface is eaten away. This process is called corrosion. For example, when iron lawn chairs are left out in the open in the rainy season, they look totally worn out after some time. This worn out look of the chairs is the result of rusting. It is the most common and familiar example of corrosion. Iron plus oxygen plus water leads to rust hydroxide. 4Fe plus 3O2 plus 3H2O leads to 2Fe2O3 3H. Reactions with water. Metals react with water to form oxides or hydroxides and hydrogen. Some metals, such as sodium and potassium, react even with cold water. Copper, gold and platinum do not react with water or steam. Reactions of metals with water produce basic solutions and show that different metals have different reactivities with water. Non-metals do not react with water. Hence, very reactive non-metals such as phosphorus, which catch fire when exposed to air, are stored in water. Reactions with acids. Metals react with acids to produce salt and hydrogen gas. Some metals react more than the others. Gold, silver and copper do not react with acids at all. This is the reason why certain food items such as pickles and curd, which contain acids, must not be stored in iron or aluminium utensils, as the reaction between the acid and metal may produce a toxic substance. Non-metals do not react with dilute acids at all. Reactions with bases. Only some metals such as zinc, lead and aluminium react with strong bases such as sodium hydroxide to release hydrogen gas. Non-metals react with bases to form salts. Their reaction with sodium hydroxide is complex. Displacement reactions. The reactivity series of metals. Natural and synthetic fibers can be reaction of metals with oxygen, water and acids demonstrate that metals have different activities. The arrangement of metals in decreasing order of reactivity is called the reactivity series of metals. Uses of metals and non-metals. Uses of metals. Metals are used to make electrical cables, wires and equipments as they are malleable, ductile and good conductors of electricity. Metals are sonorous and so are used to make bells. Zinc is used to galvanize iron and steel so as to protect them from rusting. Metals are used to make different kinds of alloys, that is, mixed metals. Mercury is used in thermometers. Uses of non-metals. Non-metals such as carbon, oxygen, hydrogen and nitrogen are essential for the sustenance of life. Oxygen is needed for respiration. Carbon dioxide is used by the plants to prepare food by photosynthesis.